Hello grade 6. The last time we had the volume, its units and their conversions. Today we will learn volume of the cuboid, how we calculate the volume of the cuboid. Okay, as we said before, the volume means length times width times the height. Okay, so if I want to calculate the volume, I multiply length times width times height. In this pyramid, or this triangle, we have here the volume times length equals length times width times height. Okay. Volume equals length times width times height. Here, length times width, this is the base of the area. This is the area of the cuboid, okay? So, here volume equal length times width times height. This is our rule. You have to keep it as your name. Volume equal length times width times height. From this, I can conclude the height if he asks about the height. If he asks about the length, if he asks about the width, if he asks about the area, okay? So, from this triangle, I can conclude any of them. So, here, if he asks about the height, that means it's volume over, it means volume over length times width, or volume over the area, if he gives me the area. Okay, if he asks about the width, or if he asks about the area, so it means volume over height. If he asks about the width, it means volume over length times height. If he asks about the length, it means volume over width times height. Okay? So here, that's what I said. The volume of the cuboid equal length times width times height. Okay? Or this is the shortcuts of them, or the abbreviation of the words length, capital L, width, capital W, height, capital H, and volume, capital V. So the volume of the cuboid equal length times width mean the area, okay, times height. Or here, the volume of the cuboid equal the product of the three dimensions. This is another way to get to tell me the rule, okay? It's the product of its three dimensions, because these are the three dimensions of the cuboid, length and width and height. So the product means multiply them together. Here, the base of area equal volume over height. Volume over height. Over means divided. Height, as we said, volume divided or over length times width, or over the area. Okay? So you have to keep this triangle, okay? If you keep it, you can get any of them, okay? Very simple. Let's see some exercises. Here, how many cubic centimeters are enough to form a cube of dimensions 17 centimeters, 13 centimeters, and 11 centimeters. Okay, I'll use my calculator here to calculate them. I'll use the calculator. Okay, here. Okay. Okay. How many, again, cubic centimeter are enough to form a cuboid of dimensions? Cubic centimeter, it means he asked about the volume, okay? So he wants me to calculate the volume of the cuboid of dimensions 17 centimeter, 13 centimeter, and 11 centimeter length, width, and height. So here, this is a way to ask about the volume, okay? So pay attention to it. So here, first of all, I write the rule, volume equals length times width times height. First of all, in any problem, you have to write the rule. Then substitute it. Length 17 times 13 times 11 equals here 13 times 17 times 11 equals 2,431. Can I leave it? Now, don't forget, the very important thing is the unit. The unit here is centimeter. Am I right? No. Don't forget the cubic. Don't forget the cubic. It's very, very, very important, because when I say the cubic centimeters, so I know that you mean the volume. You mean the volume, okay? Okay. The next one. Okay. Which is greater in volume? A cuboid of dimensions 70 centimeter, 50 centimeter, and 30 centimeter, or another cuboid whose base area equals 2,925 squared centimeter and its height equals 35 centimeter. So what is the difference here between the two cuboids? Here he gives me the 3 dimensions, and here he gives me the area, which is length times width, okay, and its height. So first of all, I write here volume 1, okay, or cuboid, the volume of the first cuboid equals 70 times 50 times 30 equals, then volume 2, the second cuboid, the volume of the second cuboid, the length times width here, this 2,925 times 35. Okay, so here I'll calculate that. 70 105,000 cubic centimeter. Okay, the second one 2,925 times 35 equals 102,375 cubic centimeter. So which one is the greatest? The first one. So the first, I write here, the first cuboid has the greatest volume, or I can write the first cuboid is greater than the second cuboid, okay? But in all cases, I have first to write the rule and substitute it, okay? Length times width times height, and here area times height, okay? Okay. Let's see this one. A juice case is in the shape of cuboid. Its base is square shaped of side length 6 centimeter. This means the length is 6 and the width also is 6 because it's square shape. So the length equals the width. Okay. Then the height is 15. So here calculate the volume of the juice which fills the case completely. It means I want the volume of the juice. Okay. So here 6 times 6 times 15. Okay. 36 times 15. 540. 540 cubic centimeter. Don't forget the unit, it's very important. Okay? I think it's very easy. If you put the rule and substitute it, you can get anything very easy. Okay. Let's see this one. Here, a carton box is with internal dimensions are 50, 40, and 30 centimeters. It is wanted to fill it with boxes of tea in the shape of cuboids. The dimensions of each box are 10 centimeter, 5 centimeter, and 6 centimeters. Calculate the greatest number of tea boxes can be put in that box. What does that mean? I want you, when you solve a word problem, to read it part by part and try, if you want to draw it, okay, to imagine the shape of it. Here I have a cartoon, okay, with the shape of cuboid, and I want to fill it with boxes of tea. Some boxes, okay, and so on. I want to know how many boxes can I put in this cartoon, okay? So he gave me the dimensions of the box of tea and the dimensions of the big cartoon to know, to get the volume of the greatest one and the smallest one, to know how many boxes of tea can I put inside the big carton. So here I write the volume of the carton or the big box. I can write the carton box or the big box equals length times width times height. Okay, and then substitute here 50 times 40 times 30 equals okay, so it's 60,000 cubic centimeter, 30,000 cubic centimeter. Then the volume of box of tea equal length times width times height equals, substitute 10 times 5 times 6. Here 5 times 6 equals 30 times 10 equals 300 cubic centimeter. Now I get the volume of the box of tea, then I get the volume of the big cartoon. I want to know how many cartons or boxes can I put inside the big cartoon. So to know, I will divide this volume divided by this one. the number, so the number of tea boxes equals 60,000 okay, divided by 300, so 600, okay, divided 300 equals 200 boxes. 200 boxes. 60,000 divided 300, okay, by this. 600 divided 3 equal 200 boxes, okay? Is it easy? Okay. Now, let's solve this one first. Okay, here the base of cuboid is a rectangle whose perimeter equals 40 centimeter. Here, he gave me the perimeter and the ratio between its length to its width, 3 to 2. Calculate its volume if its height is 10 centimeter. Okay, let's see what is the given here. What is the given? What he gives me here? He gives me the perimeter and the height. What should I need? What I need to solve this? I need the length and width and height. Okay, he gives me the height. Where is the length and width? Can I get them from the perimeter? Yes, I can. Why? If I know that the perimeter equals length plus width times 2, right? So I want only length plus width. So I'll divide the perimeter by 2. I'll divide the perimeter by 2 to get the length and width only. So here, first of all, I'll say length plus width equals 40 divided 2 equals 20. So length plus width equals 20. Can I leave them 20? No. I want to multiply them, not to add them. So I want the length separately, separate than the width. Okay, so here he gives me the ratio 3, the length 2, the width 3 to 2. Length width 3 to 2. Okay, here remember the ratio. Remember the ratio. Here 3 and 2 equals 5. So 20 divided by 5 equals 4. So here the length equals 3 times 4 and equals 12, and the centimeter, okay, and the width equals 2 times 4 equals 8 centimeter. Okay, so here I get the length 12 centimeter and width 12 centimeter, and I have the height 10 centimeter. So to calculate the volume now, volume equal length times width times height. Length 12 centimeter, 8 and 10 equals, okay, 960 cubic centimeter. 960 cubic centimeter. Okay? So, from any problem, I see what are the givens that I have, and the main purpose for me to get the length and width and height to calculate the volume. Now here, okay, here I have a swimming pool with internal dimensions 30, 15, and 2 meters. 405 meters cube of water. So pay attention here. The swimming pool has these dimensions. Okay? Then stop here. Then 405 meters cube of water poured inside it. Okay? So find the height of water in the swimming pool. Then the volume of water which is needed to fill the swimming pool to complete it, or to fill it completely. Okay? So here I have the swimming pool. Okay? And I have its dimensions. Then some water poured inside it. I want the height. I know the volume of this water. I want to calculate the height of it. Then I want to know what is the volume of the water that I need to fill it completely. Okay? So the first one, here I want the height. Okay. Here I have the volume of the water. I have the volume and I want to calculate the height. Can I? Yes, sure. How? I have the rule here, the height of water. Okay, equals. From the rule that I know, volume equals length times width times height. If I want the height, so volume over length times width. Volume over length times width. How can I know the length and width? Here, the length and width, the width here, okay, the length and width, okay, it's the same as the swimming pool. So I'll use the length and width here, the length and width. They put in order, by the way, length, width and height, length, width and height, okay? So I'll use this length and width, okay? So here, the volume here, 405 over the length is 30 and width is 15. Okay, so that means equals that means 0.9 centimeter, 0.9 centimeter only, because this is the height. Okay, so now I calculated the height. The next question, the volume of water which is needed to fill the pool completely. Okay, I have here, if I calculate the volume of all the pool, then subtract this amount, so it will give me the rest of the volume of the pool, right? Again, if I want to calculate this volume that I need to fill it completely, so if I have the volume of all the pool, okay, then subtract this amount, so the remainder will be the rest of the pool. So here, okay, 30, 15, and 2, okay, and here for, I keep the numbers, okay, 30, 15, and 2. Okay, here, it's right here. Okay, so here, the volume of the pool, equals length times width times height, which is 30 times 15 times 2 equals here, okay, 450, yes, 450 times 2 equals 900 cubic centimeter, 900 cubic centimeter. This is the volume of the pool. And I have the volume of water, give it to me, equals 405, right? So here, the volume of water needed to fill the pool equals 900 minus 405, okay, equal 495, yes, cubic centimeter. Okay, I subtracted the water that I have from the volume of the water that I have from the volume of the pool to give me the volume that I need, the volume of water that I need to fill the pool completely. Okay, I hope that the exercise covered the ideas in this lesson. Thank you so much. I hope that you enjoyed the session, and let's meet in another video and another lesson, inshallah. Goodbye.